Hello everyone. Today we're going to talk about simulation in Excel. First of all, I'm going to go over some of the basic Excel spreadsheet design simulation features. Then I'm going to show you that how we're going to simulate random variables for different kind of distributions. I will walk you through two examples. One is simulate a discrete random variable. One is simulate a random variable following a normal distributions. You probably heard about simulations such as a Monte Carlo simulation, right? Indeed, yeah, very similar. Basically, simulation mimic the real life situations. We have the models and simulate many times. Then we have a large simulated data. So this allows us to look at how sensitive is our outcome against certain assumptions. The benefit of simulation is that you don't have to go to implement the physical models. Sometimes it could be expensive, risky, or not very difficult to do in reality. So in Excel, simulation has one unique feature. Usually involves use a random number generator random as one of input parameters. We can simulate many things such as for corporate profit, retirement question, investment, stock return, price, portfolio. Okay. So there's a lot of potential to offer. Today, our class is introduction. So let's first review the simulation procedures. Typically, a simulation involves you have to specify a model. For example, we want to simulate the corporate profit. Profit depends on revenue, sales revenue, quantity, price, and expenses, variable cost, fixed cost, so on and so forth. So you need to establish a model, and we want to determine what is the outcome, for example, profit, what is the involved input variables. Now, for the input variables, you need to make assumptions. How those input variables change? Do they follow like a certain type of distributions, right? So you need to specify the distribution assumptions for input variables. So once you decided these choices, then you're going to actually simulate random variables for these input variables. So for each input variable, once you simulated random withdrawal from their distributions, you can put them together into the model and get one outcome. Then you're going to repeat. For example, you want to repeat, say, 100 times, 1,000 times. Then you simulate a large data, right? So last step is you want to look at the outcome. We want to understand more what is average, what's the standard deviation, how likely we're going to achieve certain goals, so on and so forth. So that's a typical simulation procedure. I want to give you some intuition, like how this is achieved, why we can use a random number generator able to simulate a random variable. So first of all, I don't know if you're familiar with probability distribution or not. So typically, the probability distribution will varies from the minimum 0 all the way to maximum 1. Okay, so the random number generator here, random, the parenthesis empty, also produce a number randomly from 0 to 1. Right, so it seems like a very good range. As far as the range concerned, they are very perfect match. So what we want to do, we want to simulate a random, like original x values. So what we do is that once we have a random number here, we will go to the cumulative density probability function, distributions, and match back to what's the original x we can simulate. I want to give you two examples to see if you can get a better understanding of the intuition. Okay, so don't worry about the detail, because we're not going to the in-depth about why this is happening. We just give you the idea how the random number work. So here is example of normal distributions. So we have a large, for example, large market index, S&P 500. So this is simulated stock return. We assume they follow a normal distributions where the average 11.55, the standard deviation 20.52. So then we will have normal distributions. But here, we don't have a bell-shaped normal distribution. Instead, we have this cumulative density functions. It's okay if you don't know why this is calculated, but this is already calculated for you. All you need to understand is that this is the cumulative probability on the vertical. Horizon is annual returns. Now, what we want to simulate or use random variable is we will randomly simulate a number such as 0.6. We will go to the cumulative density function here, 0.6. Then we will come back, say, okay, so this match annual return of about 16.774. Another random withdrawal, say 0.05. We come back and match. So okay, this is had a negative return like 22.367%. So this is just give you now 1 hour match. Another example, the distribution is a discrete random variable distributions. For example, we are simulating revenues. We assume there's 4 outcomes: $200 million, 400, 600, 1,000. Then we have those given probabilities. Okay, so what we do is, again, I think the cumulative density function will help us to simulate revenues. So for example, suppose we have a cumulative probability equal to 0.45. So this will help us to locate 400, a unique simulated revenues. So it's okay so far if you now don't understand because we haven't gone to the detailed procedure. But this gives you the idea that how we use a random number generator and the match cumulative density function and locate and simulate a random number for different kind of distribution, whether it's a normal distribution or discrete random variable distribution, and so on and so forth. Okay, here, right, in reality, there's a list of common distributions, such as the one we see: normal distributions, log normal, exponential. We also have uniform random, discrete,